Vegas.
Without further ado, we're very fortunate to have Steve Duplessie here. He's the godfather of industry analysts. He doesn't speak here very often, and I feel very pleased that Steve would take the time to create this presentation and come out here to talk to all of us. So give him your attention and ask him lots of questions. He has all the answers.
All the answers. Thank you. Can you hear me? Can't hear me. They gave me the crappy mic. Can I have the good mic? Where's the good?
Is this a good mic?
I want the good one. Oh yeah, I can hear that one.
Good mic.
Gives me the crappy mic.
It was a test.
All right. Is that better?
Yes.
Good. I don't want to yell. I will if I have. So first let me just set this up by saying thank you for paying rapt attention to what will be clearly one of the most important discussions you will ever have. Yep, this is going to be unbelievable. So the last nice folks from EMC tried to tell you stuff that you're got to worry about today. So I want you to first understand, I'm not going to tell you anything you're going to have to really worry about today. My objective is so I don't have a real job. You have a real job. You got to focus on, oh my God, I hope my phone doesn't ring while I'm here because some idiot did something stupid and I'm going to have to leave and go deal with it. I totally empathize and I get that. I respect enormously the difficulty of everybody in IT's job. Thank God you all are insane enough to do this, or I wouldn't have my job, which is really to kind of sit above everything, because I have no actual skill. I get to sit above everything and I get to look around and try and play the pieces. How are things going to play out? And so, to some degree, I'm a geek voyeur, which is legal still. But within my group, we do a lot of market research, and we are, like the old Mutual of Omaha's Wild Kingdom. We track you. Right? We try and figure out why you do what you do and what causes your problems to try and help industry, and sitting in the middle of that sort of ecosystem, understand what has to happen next. So as hard as your jobs are today, and for everything good, there is an evil that happens. Right? A lot of you are older than me, or as old as me. No disrespect. Some of us are old. Some of us are even women. That's awesome. That's new. Some of us are old and have been around and have seen this movie before. In this industry, probably more than any other industry that I know of, we love to talk about the exact same thing with a brand new acronym. We will change the acronym, discuss it like it's brand new stuff. Right? How many people were mainframe folk? Is this really new? Seriously? LPARs? This is really fundamentally new? No, the box might be new, the picture might be new, the economics certainly are new all the time, but fundamentally for 50 years, and I've used this 50-year number specifically, for 50 years we've effectively done things the same way. We do them better, faster, cheaper, absolutely. But effectively, from an overall conceptual level within IT and commercial computing in general, we're still doing stuff the exact same way. We stick our finger in the leaky dike over here, we create a problem over here. We solve one issue, we create another issue. Right? It's why this is a magnificently wonderful business to be in on the industry and vendor side, because no one ever gets it right. As soon as we do, as soon as we solve one particular problem, some use dynamic will occur that will completely screw up everything we just fixed. Right? No one knew that the cell phone was ultimately going to be not a telephone. Right? No one could have predicted that we would create our own language on that cell phone to do text messaging, and it would actually become one of the world's most fastest, most brilliant data creation and transmission devices on the planet. Arguably today, the single most important, fastest data transmission and creation device on the planet. No one could have predicted any of these things. And so in IT, we are very rarely, we like to theorize that we are strategic. I'm also not here to lie to you. I know how hard it is, your job. I know that your boss is an idiot. I know that. Right? I know their boss is an uber idiot. I know their expectations are outrageous. A lot of that's our fault. A lot of that's our fault because you're superhuman people. You make stuff work that has no business working. Every day. So anyway, there's some method to my madness. First of all, let me come back to that 50-year thing. If you're a historian at all, certainly in the modern era, in the last 200 years, I'll call that the modern era, any significant advancement, certainly technologically, but it doesn't matter if it's manufacturing, pick your thing, medicine, pick your thing. Any significant advancement almost never lasts 50 years before it's completely revolutionized. And we are in 50 years of IT doing stuff the same way we've done it. Okay? For a long time, you could ride a horse to work. It was a completely acceptable mode of transportation. It is still a valid mode of transportation. It's just stupid. Right? It just doesn't fit in the modern world. You can be eccentric if you'd like, but it's dumb, it's impractical. But it's still a valid mode of transportation. So eventually we evolve. What happens in IT, because we tend to be reactionary, we fight fires. You're professional digital firefighters. That's what we do. Very difficult to think strategically when, a friend of mine once had this great line, you don't paint the house when it's on fire. Right? And in IT, we're kind of always on fire. So, I'm here to terrify you and tell you that all those fires you're putting out now are just going to get worse. A little bit. And then we can talk about whatever you want to talk about from the Red Sox on. As long as the Yankees lost, I'm okay. Oh, wrong button. Seriously?
Check to see if the slider is
Slider on the on position. Yeah, yeah. Technology.
Is there an IT guy here?
there it is.
We would have figured it out. Anybody know what that computer is? Anybody remember that? That's awesome. And that's not even 50 years old, obviously. It was just the oldest one we could find that fit on a slide. So, since you were little computer science majors 100 years ago, this is exactly how the world has operated and does operate. Monolithic stacks of computing elements. Yeah, it works the same. It doesn't matter if it's a pyramid or in this particular case, that particular stack. You got an app, talks through an OS to a big stack of stuff. Right? Anything fundamentally different today? Same thing. Same thing. The root may change, the presentation layer may change, all the same things. Things get bigger, faster, better today. Like here's to, wow, what did we do? We disaggregated storage today, physically disaggregated it, create logical presentation views all throughout that stack, but it's the same thing. Everything we do today, by and large, 99% of what we do today is built on monolithic infrastructure stacks. Now, why did we do that? Anybody want to guess? I'll give you the answer. Because it worked. That's why we did that. So what we've had to do for 50 years, again, any different piece can be, this one's better than that one, mine's bigger than yours, this one's faster than this, et cetera, et cetera. But fundamentally, architecturally, everything in our world has primarily been monolithic stacks of computing. The reason that we did it is because it works. Why did it work? Is because when we could contain an application to a physical set of infrastructure, we could plug whatever holes we had to, optimize whatever it was we needed to make sure that it fit within our parameters of acceptable service levels. When we added more users, when we needed more transactions, when we got whatever else jammed down our throat, the industry responded by fixing those problems. Moore's law is why this has worked. So we've added new use cases because we don't anticipate all of them. We didn't think everyone in the company was going to be on the computer systems back in the day. They were very specific, just accounting or just whatever, engineering. They're very specific use cases. But by and large, the way we compute an application is based on build a stack, don't let anybody else touch it. Interdependencies are the death of our computing environments. Hard to fix a siloed stack of stuff with one application running. It's hard, right? Because things are so fast and so incredibly powerful. It's difficult. The tools have never kept up with the overall capabilities of the systems to be able to help us isolate and figure out what causes the problem. We can find a fire normally, and in the older days, when it was purely a single stack of stuff, you just look for the red light. What broke? And you fixed what broke, type of stuff. Red lights are hard to find today. They're virtual. Where's that? I don't know. Here's where it's a ghost, it's an image that you can kind of see there, but fixing things becomes harder and harder and harder as we move along. So the point of this slide is that 50 years ago, everything was in one box. Today, it's not in one box. But logically, it's still one box. It's still one monolithic instance of an application executing through its own, by and large, specific kind of stack of hardware. We disaggregated storage. We made it look different. It sits out there. As a matter of fact, storage was the first truly virtualized outside of the mainframe. In the distributed and open world, storage was the first truly virtualized stuff. And by truly, I meant we made something that was physical look different than it was. Fascinating. Virtualization 1.0, the age of consolidation and utilization. How many of you are completely consolidated perfectly and get optimum utilization now, just in your servers? Forget everything else because you don't get it everywhere else. No. Right? We're still just on that path. This is all just kind of happening in real time. Sure, you've been at it for 5 years, but we're not there. We're not done. And this is interesting. I'm going to call it the beginning of a serious evolution, potentially the revolution beyond that 50 years that I talked about. Very important step along the way. Disaggregating the physical from the logical is paramount, not because we don't like the physical. It is paramount because the only way we ever ultimately strive and take forward significant steps is when we do things that eliminate the human being from having to be in the middle of it. Automation is the only way we ultimately take real aggressive forward steps. So when I put that first monolithic compute stack up there, and you all know, oh, it's a compact, whatever. You know, in the old days, you had mini computers. Those were our corporate computers with VAXs, stuff like that, Wang, Prime boxes, whatever. If you think about administering a system back in those days, you, the sysadmin, who today is the virtual admin, right? Nothing ever new happens. We just keep going in circles. We specialize, then we collapse. Specialize, collapse. The sysadmin back then had to figure out, I'm going to put up an application and I'll put all-in-one up on the VAX. I have to figure out how much physical main memory I'm going to allocate to this application to execute. How much page and swap space am I going to allocate to this system to execute? You had to figure that out, and no offense, you are imperfect. Because you can figure something out right at some point in time and you can be the best in the world, but things are going to change. Your environment's going to change. And you have to be responsible way back then to be able to twiddle whatever knobs you had to twiddle to make sure it was always optimized. And what happened? Kicking and screaming over the course of time, you stopped doing that because the operating system was way smarter at it than you. No disrespect. It didn't have to go to Little League. Or it didn't have a real job. Right? It just sat there. The computer is smarter than the person at heinous, tactical, manual labor. But as human beings, we hate giving up those control elements. It's also part of our problem. So, we talk about virtualization 1.0. What did we do? Our problem that we solved with VMware, which by the way, VMware solved 10 years earlier. It just wasn't a market problem, a test dev problem. But our problem that we solved was a utilization issue primarily. We had a lot, Moore's Law surpassed our ability to consume. All of a sudden, cores were no issue. MIPS were no issue, VOPs were no issue, whatever it was. We had tons of processing capability that we couldn't possibly use in our current manifestations. So because we ran one-to-one relationships, application to server, physical, all of a sudden we had a zillion servers all over the place that were all terribly utilized. So the theory was, gosh, we could consolidate those, get rid of a whole bunch of these physical boxes, and virtualize, and make one physical look like 6, 10, 58, I don't care, however many, virtual machines, and allow applications to not know that was happening. Containerize that application, still thinks it's in a physical stack, still operates essentially like it's in its own physical stack, way better utilization of the server. Interesting dynamic. 30 years ago, the server was proprietary, complex, enormously expensive. By far the single most expensive thing in our infrastructure. Storage was a disk drive we plugged in. How simple. Now, the world's awesome. We virtualized stuff that costs nothing. Servers are free, by and large. Processing capabilities are free. And what's enormously proprietary, tremendously complex, and cost a ton? Storage. Interesting. God bless you. I was a big fan of that. I was part of that. I take no responsibility, but I was part of it. By the way, I'm biased. I'm in the genius. I was at EMC in '86, left in '89 because I knew they'd never make it. I wouldn't listen to anything I said. I'm just angry. Very bitter. So anyway, now we've got these super uber core mega servers that cost 62 cents connected to storage, and that's virtualization sort of 1.0 type of thing. And then what we had to do when we went down the beginning path of this, we realized, ooh, in order to do that, we're not really just going to have one physical server. We're going to have a bunch of physical servers that we're going to have even more virtual machines on top of. So it forced, even after 30 years, it forced us to move to external network storage. And that, it didn't matter what the emphasis was. That's the right thing to do. Because ultimately, we need everything connected to everything, irrespective of the protocol and the wire, etc. In order for any of this stuff to kind of work, everything's got to fundamentally be connected to everything. So we moved down and we built this new, the whole super uber industry, $50 billion storage industry. It's awesome, right? It's awesome. And I look at a lot of the advancements that we've made by commoditizing the server. Server's just processing capabilities, flash, cache, memories, and I/O. That's all it is. All the advancements we've made there, and yet I look down into the storage and go, God, that's so 1988. And it might be really great 1988, but whew, I'm going to show you some of the problems. Maybe. Virtualization, because, again, we have a wrapper inside that primary server, virtualization has caused I/O problems for the first time in decades. Because again, when things were physical, located on stack, you could maximize and optimize that stack to be able to handle whatever workload you needed. Things got slow, you knew what to fix. Ooh, I can't get enough throughput, great, I add bandwidth. I can't get enough I/O, great, I add spindles. And whatever the patch of the day is. Solid state, et cetera, et cetera. But you knew where the problem lay. You knew what your system could handle, and what did we do? We always built for peak doomsday scenarios. So our infrastructure stack in days of old was the opposite of consolidated and well utilized. Because we built for the Victoria's Secret moment. 50 million people are going to get online. And then 99% of the time, we have way more stuff than we're going to use. Right? Bad math, good output, good performance. We don't want the phone to ring. Hey, you stink. Right? You have a thankless job. No one ever goes, hey, nice networking. Right? No one says that. But the nicest little old lady will kick you right in the butt when their email doesn't work. I can't get that Facebook picture. Terrible people. So, virtualization, as you all, anybody that's been through this, has created a set of brand new I/O problems we never counted on, because nobody knew this was going to happen. right? Nobody knew. We containerized. Why does this happen, by the way? It happens because one VMDK executing one application has a specific workload profile, and all of a sudden they mix and match with another VMDK right next to it. Those interdependencies that didn't exist in the physical world all of a sudden exist. Worse, they're transient. Something happens at 4 o'clock that doesn't happen at noon. These three things happen at 3 o'clock that didn't happen at 6 o'clock. And so not only do they create these problems come in and go out. So how do you fix something like that? In the old days, we fixed something by going, oh, I can understand the problem, and I optimize to the problem. I solve for that because it's a constant. Right? 9 to 5, I have 5,000 users that do X. And we can solve for that. This is a different world. This is a massively transient world. The problem, by the time you solve the problem, it probably doesn't exist. And then it shows up again 4 hours later or 4 weeks later, whatever the case is. So these make it hard enough. The solution from an I/O problem perspective today in a virtualized world is to do exactly the opposite that we're intending to solve on the other side, which is to typically over-provision. We buy more stuff, more spindles, more cache, more controllers, more stuff than is optimal from an economic perspective, simply because we can't deal with the phone ringing, and why doesn't this work under this set of conditions? Make sense? Problem 2, perhaps the worst problem today, and it's still tail of the dog, it still follows everything we've ever done. Visibility was hard in the physical world, it is brutal in the virtual world. What is the cause and effect? We know the effect, we rarely can figure out the cause. Right? It's really, really hard, so I'll give you my humorous anecdote. When everything was systemic and holistic, and the phone rang, and somebody said, why is this slow? The team, sysadmin, all the associated people would get together and kind of scrub through and figure out what changed. It's all about change management when something's bad. Something was good, went bad. What changed? We identify the change, we correct the change. Today, Friday, everything worked great. Monday morning, people are screaming. The business line is screaming. Nothing changed. What happens? VP Ops, whoever it is, gets the team together. Sysadmin, network admin, storage admin, DBA, whoever owns the app, storage guy, on and on and on. Whole team get together. Okay, fellas, ladies, something happened. Go figure it out. What happens? We scamper back to our individual cubes and we look through our very specific myopic set of tools, because I'm the storage guy. I go through my storage logs, and the DBA goes through their logs, and everybody else goes through their own logs, only to stand up and go, not me! Not me. That's not helpful. It's good for you. Way to go, it's not you. But it's these interdependencies and the lack of our ability not only to functionally to see things, but we've gotten used to over the last 15 years of not even talking to each other, because we've gone through the age of specialization where I don't even know how to talk to. I don't know what that guy does. He's a geek. Right? Very difficult. So all of a sudden now we're kind of forced back into a world where thou shalt communicate. And this is good for humanity, by the way. It's good. You know what's the difference between an introverted IT guy and an extroverted IT guy? The extroverted IT guy looks at your shoes when he's talking to you. Just kidding. I usually say engineers, but when in Rome. All right, second, here's my joke. System management is a brutal black art. Brutally difficult for all the things we just talked about. So here's how I can try and explain it to my wife. You had a cage, and you took a few monkeys, you put monkeys in the cage. You set up a ladder in the middle of the cage, and you hung a banana from the top of the cage. Invariably, one of the monkeys was going to climb up that ladder, grab that banana. That's what monkeys do. If you did that, and that happened, the same time that monkey grabbed that banana, you took a freezing cold fire hose, and you squirted the heck out of the other monkeys in the cage. It would not take long for those, if some monkey started climbing that ladder, the other monkeys would beat the hell out of them, right? It would not take long. Fast forward. Now if you rotated out those monkeys one at a time, new monkey comes in, old monkey goes out. New monkey's never seen the situation. Monkey comes in, says, that's a banana. Nobody's gonna get that? And invariably will climb up the stairs, the other monkeys will beat the hell out of them. Right? You can rotate every monkey out until there are no monkeys that have seen this situation before, and invariably, one will try and climb up and the others will beat the hell out of them. They just have no idea why. That's system management. Right? I don't know why. Right? I should just end on that one. All right, so visibility, really hard. Really hard. We have not kept up because, again, with so many different physical interdependencies, is if an EMC box on one end, you've got VMware in the middle, you've got HP on the top, you've got Cisco in the middle, kind of stuff. There's still all sorts of these disparate interdependencies. Part of the reason, by the way, that this whole notion of the consolidated stack is getting play. Because theoretically, and that's not true in reality, but theoretically, by and large, if you could just go to, wow, I can get my brain around if it's one vendor that had control of everything, that would have to make it easier. And that's working from a marketing message perspective. Not necessarily 100% advocating it, because it's not like HP knows what they're doing all the way down the stack. You know what I mean? But anyway. So just to make everything worse, which you didn't think was bad enough, we combine mobility. So just in case you could, oh, I see the red light, we go, no, we're putting it over there. Right? It's awful. So it was hard enough, we had interdependencies within some container. A VMDK acts like X over here and Y over here. Now we're gonna move them around. It's part of the brilliance and the allure of the whole virtualization principle. Right? It's fantastic. We have to enable this to occur, but whew, we're still treading water, and somebody keeps diving in and doing cannonballs. Follow my logic? Here's where we're going. Sorry, I'm cool. Making one great physical box look like 6 virtual machines is awesome, but that's not interesting. That's a utilization consolidation play that we had already talked about. What's really interesting is making 6 physical boxes look like 1 to an application. Because once you can do something like that, you break all the physical boundaries associated with the resource collection within those physical boundaries. What's in a box? Bunch of cores, bunch of memory, bunch of I/O capabilities. It's in a big disk array. Bunch of disks, bunch of capacity, bunch of cores, bunch of channels, bunch of I/O capabilities, et cetera, but restricted to within that box. So when we can, spin up a virtual machine or an application instance, virtual or physical, within some particular thing, and we need something more, wouldn't it be great if we could get it wherever the resource was available? Unrestricted, right? Follow me? So we could stand up and tear down dynamically on a very transient basis whatever assets and resources that application needs for that period of time. That's cool, right? That's the ultimate in effectiveness. Because even in your own shops, you've got physical server A, physical server B. Physical server A can be completely wiped out at 4 o'clock because you're running X jobs, but having a physical server B sitting there doing nothing. It happens every day, let alone when you have thousands of these things. Right? It's invariable that that will happen all the time. So what if, because what we're really focused on is prioritizing application importance, SLAs, application value, well, that's where we focused our time and let the magic system, I kind of call it the data center operating system, that VMware aspires to be, by the way, which is dangerous. But if that could happen, and it could just view all the resources within our data center as a collection of stuff that it can pick and choose and put together and stand up. The hard part's been done. We can build a virtual machine. That's hard. It was hard to do. We have to take a piece of a core, a hunk of memory, not all of it, right? Some I/O capabilities, some storage capabilities. That was really hard to do, but they're all bound still. They have physical boundaries associated to them. What if they didn't? And then my argument is sooner or later, they're not going to. Right? And I think I could prove that exists because we do grid computing today. Most of us not commercially, but grid computing has existed for a long time. And principally I bring this up because that's just a relatively simplistic example to understand that if I can massively parallelize an application, the application does not know it's executing on 700 physical machines. It does not know. It does not care. Eventually there's an orchestrator that's kind of running jobs in parallel, little pieces of that application's job load, and then putting things all together. But that application doesn't care. It doesn't know it's got 700 machines underneath it. It only has a one-to-one relationship as far as it's concerned. And so this will happen, right? Where does it not happen, we already talked about that, doesn't happen in storage. So it's great, and I do love EMC. I do. So I don't want you to take this the wrong way, but I don't care who we're talking about. EMC, NetApp, IBM, blah, blah, blah. We're moving in a grid world on the server side really fast. We're moving in a grid-oriented world on the networking side really fast. We're moving backwards on the storage side. Our most elaborate, most expensive, awesomest, highest tech, coolest storage today is still monolithic clustered stuff. Active-active, active-passive. Kidding me? I got thousands of physical server nodes connected through 2 RAID controllers, 4 RAID controllers, 8 RAID controllers. A big cluster, a big scale-out cluster is 16. There are examples that it goes more, but from a market share perspective, I mean, 2 is 99% of the market. 2 controllers from access perspective. That's counterintuitive to me, right? That doesn't make sense ultimately long term if we're going to start spanning across physical boxes on the server side. We have to be able to keep up. So you're only as fast as your slowest point. Right? And all of this stuff doesn't matter. It doesn't matter if you're talking about 10 servers or 1,000 servers. Eventually you get bottlenecked down to whatever your most throttled point is. Today your most throttled point are storage controllers. That's not going to get better. It's going to get worse. Now the EMC and everybody else does a great job making those storage controllers as awesome as they can be, fast and fast and fast. But the ratios of what comes into what goes out are still just ridiculous. And more so, right on the back end of a RAID controller, you might have 1,000 drives now. All funneled through 2, 4, 6, 8 choke points, up to 1,000 servers. Fundamentally wrong. Sooner or later, that's where the bottleneck's going to live. Sooner or later. You're only going to be as fast as your slowest point. So the industry's eventually going to get there. But what's going to happen, I think, is just like virtualization caused you to network storage finally, even though we had SAN and NAS for a zillion years, and it was always the right thing to do, but it took server virtualization to make it really happen ubiquitously. Same kind of thing is going to happen here, my estimation. The capabilities of the server side and the network side will push you because, and oh, by the way, I don't blame the storage industry. Because as long as you keep writing checks, why should they change? EMC makes a lot of money. NetApp makes a lot of money. These guys make a lot of money. But there's no reason to change because you don't make them. And it's difficult. I understand it. Fundamental business 101. You're going to keep giving me a buck for something, I'm going to keep taking it. It'd be dumb not to. These are not altruistic endeavors. They are not here to make you happy. They are here to take your money. The stockholders, the way of the world. And it makes them happy, really. You are here to serve them, if you think about that. Anyway. In the future, the only way that this can work is one of three ways. You can't have these choke point storage controllers as we know them. So the storage controller itself has to become virtualized, truly virtualized and distributed and gridded in at least widespread cluster. And that might mean that the virtual storage controller executes down at the physical storage layer, right? There's a couple of guys that are sort of doing this now grid-wise. Core8 and GridStore are good examples, I think. And there's a whole bunch of scale-out folks. Isilon was brought up, you know, and others that are in there that are still, I would consider clusters more so than grid, but it's happening, right? It's starting to happen in that respect. But it could also execute, since it's virtual, it can execute anywhere in that stack. And so right now we don't see, 10 years ago we had the intelligent switches, storage switches. That was going to be the greatest thing ever. And a lot of that heavy lifting was going to happen at the port, which is logical. If there's enough processing capabilities at the port, everything has to traverse that port anyway. So why not put it there? Made sense to me. Ultimately, it's either going to be down the bottom, I think, or it's going to be up in the top. Why isn't it executing at the VMDK? Why doesn't the VMDK have its own storage controller married to it? Goes anywhere the VMDK goes, storage control is already with it. Need more bandwidth? Add another virtual storage controller. That's kind of the, I think that's how GridStore is doing it. They don't only do that, but at least conceptually. Nor do I have any idea if it works, but sooner or later it has to be like that. Follow? Questions, comments, arguments? There are no stupid questions, only stupid people. The data center, right now, the container is whatever box we carry stuff in. Server container is the server box. Storage container is the storage array. Right? And we're bound and restricted within those. Now, some of those, I put up that picture of the wall of storage that's set up there. Each one of those, you know, was a storage block, we'll call it. And logically, we might connect a whole bunch of them together to still make it, from a management perspective, look like one. In the future, the data center is the container. Everything else is literally just a carrying device. The data center itself has a collection of all sorts of disparate processing capabilities, memory capabilities, I/O capabilities, network capabilities, storage capabilities, that no one size has to fit all. Somewhere there's this uber orchestration layer, the data center operating system, for lack of a better term, because I haven't thought of one, that's the power function of the next century of corporate computing. If corporate computing stays within our purview, it doesn't all run out to the cloud. But somehow, even if it is at the cloud, that's how the cloud's going to operate. Right? That's from an operations perspective, how the cloud has to operate. I'll show you some more examples. But it takes what it needs when it needs it and then gives it back. And the simplest way to kind of think of the next step on how we do that is that, how do I make two physical servers look like one to that app? Because once you can do that, you can do this. Shoot.
Storage is not the issue, it's the data in the storage. And data is not ephemeral like cycles or like electrons on a wire.
Yes and no. So the comment, excellent comment, was storage isn't the issue, data is the issue. Data is not ephemeral like any of these other things I'm talking about. And what happens in a grid, so here's the, I guess, net. Name your favorite cloud example in the modern era that computes what you use. I mean, Amazon or Google or somebody like this. None of them use any traditional architectures. None of them. They compute, do more transactions than anyone in history has ever done. They do more anything than anyone in history has ever done. And none of them have any of these restrictive covenants. What happens in all of their cases is, to one degree or another, because they'll never tell you, they gotta shoot you, but it's replicas. So it is data. It's having enough copies of the data to have enough access points to be able to satisfy whatever that ultimate requirement for, be it performance or bandwidth or whatever.
Right, but they've gone to eventual consistency rather than real consistency.
Correct.
So
No.
You
Look,
gotta rewrite your applications at least.
and at the very least, what will happen at, let's say, X years, I don't want to put a date on it because I'm always too far ahead, is all the applications will be written to take advantage of that. Today, they are not.
They said that in the 80s about parallel processing.
Yeah.
How close are we today?
But,
Not yet.
no, not yet, but did they have to do it? What, they didn't have to do it. They said it's much easier for a monolithic stack. I don't have to rewrite. Nobody wants to do the work if they don't have to do it. Yeah, you know what I'm saying? As long as Moore's Law kept up, I didn't need to do it.
Right, but now we're.
At some point, you break that. So it is it's a great discussion. When Amazon started a company, they did not start to be S3. Amazon started a company to say, we're going to revolutionize the way retailing works, and we're just going to take a toll on order. We're the ultimate order entry system and logistics control system. And we're going to take a little toll on every one of those. All these other capabilities were outshoots of that. Now, when they started this business, here were their requirements. We have no idea how many orders we're going to process in a day, but we think it's going to be huge. When we need to scale right now. Since we have no idea what our business is actually going to look like, we can't possibly commit to spending money. So we need to be able to scale instantaneously with the ultimate commodity stuff. Has to just work. There's no such thing as downtime. There's no such thing as any of these things that somehow you all have accepted in the real business world. All these other things. And industry went to them and said, yeah, we don't do that. But we got a really big $1 million thing here that's cool. Would you like to buy that? Now, conversely, so they had to build their own. They had to build their own way to do this. It would have been much easier for them to just go buy it from whoever, HP, EMC, IBM, whatever. Right? But none of them do that. They all rolled their own in some sort of uber grid-based, super secret, thing that is clearly not perfect and it's not for every application today, but it worked for them in their types of thing. And all I'm suggesting is that ultimately infrastructure has to kind of play out that way. Preferably not with wires sticking off pizza box trays and, as far as the eye can see, a little bit more grown up than that, but in some manifestation or another. All right, I think I'm running out of time, so let me go. So a lot of, I guess what I'll leave you with, and these are just some examples, is virtualization changes everything. And what I think the best thing that you can, whether you agree or disagree on when the end is and how the end comes, is not so much the point as it will change and we will continue to move down a capabilities path and it will force us to do things differently. And one of my favorite things, because I have ADD, about the whole virtualization thing is it broke everything. It broke everything, every fundamental process that we had. Things like backup, which we've been doing badly for 1 million years. It made us do differently. And when we are forced as humans to do something differently, we get a chance to pick up our head and look around and say, is there a better way? And industry loves that. Startups love that. Right? New value is created in our organizations, outside our organizations, if we can do things a better way. Is there a different way? Just to think about it. And that, if nothing else, I'd just like to kind of walk through a few of these and talk about that. I give some examples. These are clearly not all the examples. But you don't see, when I talk about backup, I don't talk about Symantec. Who owns the backup market? I don't talk about net backup. Or any of these other kind of 1975 companies into that. Because now don't get me wrong, they still own all the market share. So I'm a realist. But having said that, there's better ways. I think in this particular case, I view things as, I'm a simple guy. There's production data, and everything else is a copy of production data. It runs our business in 72 other ways, but they're all copies of production data at one point in time. Otherwise, whether it's tested dev or data warehouse, doesn't matter. They're copies of production data. Why do we treat, this is interesting to me. Production data is run on the most expensive stuff, controlled by the most talented, expensive people. We put our biggest assets, our biggest budget, everything on the production system, transactional systems. Runs them. Big iron, awesome stuff. Then we take copies of that and we go, we got a data warehouse. The data warehouse is not a transaction system, but we buy all the exact ridiculous stuff that cost $1 trillion, and we just sit it over there till some marketing buffoon goes, I haven't asked it a question, right? And then we do that like 6 times, because we go, well, customer service needs that, sales needs it, clearly marketing needs it. But we're replicating 6 times the most expensive stuff that we have over here that we don't use anything like the same way. And we go, and who wins? Larry Ellison wins. Right? And Larry's going, why is that in a relational database? Why is that stuff in a relational database? Are you kidding? Oh, tough. It's the greatest sales thing in the world. It's like every sales guy's dream. You have to give me money or I'll kill you. Sales by terror. All right, I'm jealous, so Oracle's cool. All right, so the network, Chris asked me to talk a little bit about this. You guys probably saw it. VMware paid $1.3 billion for a company doing $5 million in week at best revenue, right? Nicira, why? And now don't get me wrong, I have no idea if it was the right thing for them to do or not, but conceptually I understand it. And why is because VMware wants to control the entire world. I don't blame them for that.
They want us to give them money.
Right, they're going to be the next one. VMware wants to be Microsoft and Oracle, etc. And I don't blame them for that. Right? This is a wonderful country we live in. You can do terrible things for stockholders. Anyway, Nicira meant for VMware to be successful, it has to control and puppet master and orchestrate all the things in that data center. Not just those little pieces of VMDK. It's got to own the file system. It's got to control the storage layer. It's got to control the network. And these are the types of things. So if you think about it, networks have been by and large monolithic as well. There's a whole new wave of really smart networking stuff, of which Nicira hopes to be, that can tear up and tear down and build up and rip down virtual connections ad hoc at will. And when you think about what I talked about previously, how do you take a collection of resources and apply whatever that app needs for that point in time, you have to be able to do that in the network. And so that's kind of their bet there. Will it ever pan out to be worth that much? I don't know. That makes me worth 300 million billion. I don't know. I talked a little bit about the consolidation play. You know, a lot of what we end up doing, here's how our whole industry works. When we have a problem that manifests itself, and I don't care if it's data domain or what, pick your inflection point in time, what happens is if you're an incumbent vendor, a little startup comes out and says, I built this to solve this problem. And that's what these kind of guys do. Or Data Domain did, or someone like NetApp 25 years ago did, or EMC 35 years ago did. They say, we purpose-built this to solve this problem. What do the incumbent vendors do? The incumbent vendors don't want you to give them money to anybody else, so they go, first thing they say is, oh yeah, we got that. That's coming. That's in the next rev. It's easy. We can totally have that. So they'll try and freeze you. Well, first thing they do is they go, that's ridiculous, that's the crappiest startup ever. They're totally going to go out of business, we're going to crush them. So why would you ever spend your money there? Then, once you start spending your money there, they go, yeah, but it's in the next release. It's in the notes, you can see it, it's a PowerPoint. Right, we're going to have it. And then they come out with it, they bolt on the solution to their existing legacy product, which already sucks by now. Right, and they plug that in and they go, yeah, we're going to solve it with this bolt on, and it's terrible, and then they buy them. And the big vendor buys the little vendor, and you go from there. So the purpose-built guys, you'll start to see more of this. You guys build stuff for a virtual, to create sort of pods within that virtual data center, not just old stuff bolted together. Not just 1985 servers bolted to 1992 storage, and we call it whatever we do. So probably the single most important thing, and the best news for you guys, is that skills are way lacking in any of this stuff. This is complicated, difficult stuff. And across the board, you want to get a pay raise, you want to get your next job, you're in a good spot. But you've got to get smarter about where and when, what to invest in yourselves. Because the stuff is going to become more complicated before it gets any easier. And no one's gonna throw you out the door and automate things and just say, yeah, your competition, by the way, is not each other. Right? Your competition is Amazon. And whoever else in that cloud can convince the business that it's just way easier to swipe a credit card and go, I don't wanna hear you anymore. My printer doesn't work, I hate you. You know what I mean? It's just easier for the business to try and
There are
come.
no printers in hell.
Virtual printing. It's just gonna go, yeah, it's gonna send you an email right away, go, yep, job's done, printed great. Looks awesome, you want glossy paper? They charge you a nickel. Blah, 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 you can read this later. Everyone's going to go to the cloud, if you're already at the cloud. My entire contention in all of this is we need to be able to provide on-demand cloud-like services and stop talking about it to our own constituents, less we ultimately will marginalize ourselves, and I don't want that to happen, because God, it would be bad if I had to get a real job. I think that's what I said, yeah. VMware, there you go, they want to control everything. Don't, non-altruistic group of folk love money. Good for them. That's not a bad thing, but understand, right? They will try and, no company in the IT space in the history of IT, outside, and this was just because it seemed like they could do it, of IBM, really can control everything. Nobody does everything perfectly, as you know. And so as long as you're going to take best of breed, at least in certain cases, best of breed technology, VMware is not going to be the panacea. It just is, history has proven time and time again they cannot control everything. Nor is it healthy that one person controls everything. It is unhealthy, because that's when they become Oracle, and you get a lot of that. That's bad. So get smarter, stop fighting, right? Accept some of this stuff as inevitable. You don't have to ride a horse, don't ride a horse. Ride a horse at home, not to work. It's a pain in the ass on $4.95. All right, I'm done. Anybody have any other questions? I'm sorry if I kept you over, but there was no clock, and sometimes I just talk. Questions, comments, anything at all? Nothing? All right, well, enjoy the rest of the show. I'll be up here.